Thanks, everyone. My name is Amy Krishnamohan. I do product marketing at Google Cloud. I'm here with really exciting guest speakers today, Joe and Seth from Kolide and the Six River system. So we are going to talk a little bit more about this, how you can build a SaaS application, the cloud-based infrastructure. So SaaS has changed a lot, right? When you had more on-prem hardware-based environment, having a single tenancy was actually really expensive, but it's very secure. But cloud infrastructure actually made a really drastic changes in terms of making these instances available very easily at your hand. So SaaS is obviously making a leading changes in that area. So here I'll really introduce our guest from Joe. Would you like to take it from here? Yes.
Hey, I'm Joe Hughes, Director of DevOps at Six River Systems. Six River Systems is a robotic company. When you get things shipped to you from the internet, we have a big hand in making sure that those things can get to you in 2 days or faster. And I was previously at a company called Amazon Robotics in that space, and you probably know them as Kiva. They solved the same problem. So that's our robot. His name is Chuck. And essentially, Chuck leads a worker around a warehouse using kind of self-driving technology, identifying objects in the way, and taking that person to fulfill your order of toothbrushes or whatever you happen to order off the internet. This is what those warehouses look like. So this isn't your Home Depot or your Target store. This is thousands and thousands of products, million-square-foot warehouses, and so we have algorithms in the cloud that helps us batch these orders and get efficiencies for our customers and make sure that Chuck or the mini Chucks that are in these warehouses coordinate together and make life better for our customers. So if you're not familiar with warehouse robotics, traditionally what you would be doing is carrying around a big cart weighing upwards of 50 to 100 pounds. Now you can follow Chuck around and have a more enjoyable workday. Basically, this is just a quick look at our high-level architecture, and this is kind of what Amy was alluding to. Is we have a Google Kubernetes engine cluster, which is Kubernetes is a container scheduler, where we create what are called namespaces, which basically isolate customers from one another. We actually run these namespaces on dedicated nodes, which is like dedicated compute. And we actually have a dedicated SQL primary and a read replica for every single customer. So that means that data from one warehouse never gets mixed with another. So that's a little bit about what I do and what my company does. I'm going to hand it over to Seth to kind of fill you in on what Kolide does.
Hi, everyone. I'm Seth. I'm an SRE at Kolide, which does sort of infrastructure analytics and security analytics. Previously, I've been at Fastly, Twitter, ActBlue. I like infrastructure as code, data simplification, stuff like that. Kolide builds an endpoint that hangs out on devices, primarily laptops, and collects analytics about that and sends it into our cloud, where we do some analysis on it. We launched Cloud, which is our SaaS offering, about a year ago now. And in that, each customer has an isolated namespace, very similar to what Joe is doing. And each namespace has its own little stack of application, server, and data processing elements. And those backhaul to dedicated Cloud SQL instances. So we kind of did that because it reduces the noisy neighbor problems. It also shifts the burden of data isolation from application developers to infrastructure. Right? We dedicate infrastructure resources to ensure data segregation, and then we can take it out of the application. We do share our edge ingress, so edge is shared, and it then comes in and gets sort of pushed into the back. We use Kubernetes quite extensively. We follow the operator pattern. So each customer has a custom resource definition, and then an operator goes and reads the CRD, spawns the namespace, creates many deployments. Each one brings up things, brings up Cloud SQL. we started running into issues around the number of namespaces and things that can be in a single Kubernetes cluster, so we have multiple Kubernetes clusters now. We found that some of the spin-up times were a little slow, so we started pre-creating unallocated customers and then on sign-up would allocate them. We are very soon launching a new product next week, which moves away from the single-tenant architecture and starts sort of revisiting multi-tenant designs. So that uses foreign keys for customer data isolation. And we can sort of, this is enforced at like a data layer by making sure there are effectively SQL where clauses all over. So it's basically in our data library. And we could chart that by customer to separate backends. I think that's all I've got prepared.
Great, thanks. So before we get started, there's a Dory open in your mobile app. So if you have any questions, feel free to submit a question. We'll take the questions at the end. And so there are many ways that we can define the multi-tenant environment, right? Everybody defines in a very different way. So how would you define multi-tenant in the cloud environment?
I guess I have the mic, so I'll start. I think there is a whole lot of ways to think about that. We run in Google's cloud, so inherently Google's cloud is multi-tenant, like probably almost everyone in this room is in Google's cloud. But we run on our own Kubernetes cluster, but our Kubernetes cluster is also multi-tenant because we only have, many of our customers are in the same Kubernetes cluster, so our Kubernetes cluster is single-tenant. But each daemon or pod inside in Kubernetes, workloads are sort of grouped by pod. So a pod is like a set of linked containers. And each pod is single-tenant, so only one customer is in a pod. And our underlying databases, we use Cloud SQL. We have one Cloud SQL instance per customer. So that's also a very clear single-tenant. So it kind of depends on where you look at it. I would generally describe our cloud product as being single-tenant, since Google Cloud being multi-tenant isn't really very interesting, but like our application servers and our database servers are.
Yeah, I don't really have much to add to that. I would say that a lot of it also comes down to your business problem. And for us, when we considered what we should build, and we were like, well, we have long lead times with our customers, and they may or may not want us to upgrade them. And so, what is this architecture called? And it's called single-tenant because we have really tight control over how our customer environment is managed. That works well for us, but if you're building a social media platform or something like that, probably not the right architecture for you.
I see. So you're defining as like single-tenant is having a customer per pod, and then also each single customer will have a dedicated database instances. Right.
Yeah. We go a step further than Ceph, where we actually have dedicated GCP, like Google Cloud Platform nodes that Kubernetes will only schedule customer pods and customer workloads onto those dedicated nodes. Where I know Ceph, as he spoke about, his is more multi-tenant, where a customer's pod can end up on any node and they may move around. But whereas ours, we try to protect our customers by having dedicated compute. But Kubernetes is so flexible that it makes it easy for Ceph to do his thing and for me to do a little bit different.
Okay. So when you design your architecture, what was your biggest consideration?
For us, it's really about customer stability. I think everyone here would be really angry if the socks that were guaranteed to come to you in 2 days were there 2 weeks later. And if we caused that because our system was down for some reason, for some amount of time, then our customers aren't going to trust us. So, we have to really guarantee that customer A, the noisy neighbor problem, it's just not even, we can't even let it enter the equation for our system.
We had two major drivers for going single-tenant for our last product. One of them was to reduce noisy neighbor a lot. So again, one customer does a lot of stuff, basically starves the resources of other people. So we started splitting up resources. The other reason is just around data isolation. Again, it makes it very easy for an application developer just not even think about it, right? You can be like, oh, there's no way I can select data for the wrong customer. It's just that app server doesn't have access to that. So that was a big driver for us.
I see. Okay. So going back a little bit more into database side, have you guys ever tried putting a multi-tenant in a single database, like maybe separating them by the key or by table, things like that?
So we do, actually. So I mentioned we're launching a new product. Our new product has a shared database.
Yeah.
So each customer has their foreign key constraints. Every piece of data is linked to a customer ID, and there are where clauses all over. But again, it's just this trade-off of, are you doing the data isolation work in your application at the SQL level or at an infrastructure level? So go both ways.
Yeah, so our company, another factor of why we haven't looked into that situation was just time, right? Like, we knew that there would be trade-offs and that it's more developer time to do those sort of things. And so where we can shift complexity away from our developers and shift it onto Google, which is what we were really doing, that made it an easy call for us to just continue with that model.
Actually, as I think about this, like one of the ongoing trade-offs for us around number of instances is just like straight up number of instances. When we had 10 instances, it was easy, but like as the number of tenants we have increases and increases, we're suddenly now managing, or Google is managing, many, many, many Cloud SQL instances, and it mostly works great, but as a single person managing them, it gets much harder for me to track down problems. So the number of things to pay attention to, I don't know.
I see, interesting. So now that we talk about instances, so I'm sure when your customers create some of their account in the application, I'm sure they want kind of instant creation, right? But creating the database instances or node or the pod, it takes time. So how do you manage that latency issue?
I'll start. So we have sign up is available online, so people can just kind of go, hey, I want to sign up. And we used to have a slightly asynchronous sign up flow. People would click sign up, we'd send them email, and then they'd click their email. And behind the scenes, while that email was being delivered, we would spin up a database, we'd spin up a tenant.
I see.
And we had a couple of issues with that. One of them is that we wanted to close that loop even tighter. We didn't want people to have to wait for their email. And the other one is occasionally instance creation would fail, and we never really built failure handling. So we solved that by pre-allocating things. So we have a little daemon, it runs in the background. It says make sure there are roughly 30 free tenants at any given time. So we just sort of have headroom. And then when someone signs up, it says, hey, give me the next free one. Gets a free one, then it basically says this now belongs to this company, and then it's used. And then, a little while later, the daemon goes, oh, hey, look, I need to create a new free one. So we've sort of tackled that loop by having a pre-created model.
How do you come up with that 30 unallocated instances?
Just kind of made it up.
It's a random number?
I looked at what do we get from a day of signups, what's our peak, how much headroom do we want to have lying around, and I picked a number. We used to adjust it more often, but now it's
no AI and machine learning predicting.
Nah, not on that one.
For us, it's a little bit easier because you can't just go online and sign up for Chuck. You have to engage with our team, and there's a long integration period where we have to integrate with customers' systems. So 10-minute creation time is like lightning fast for our industry, and we're really happy with that.
Great. So it seems like you both guys are using the Kubernetes right now. So how do you use Kubernetes in your SaaS application?
Yeah, you saw a little bit of that in my slide, whereas I think Kubernetes is really great because of its flexibility, where you can isolate things by namespace. Istio can. We have a lot of customers that are very concerned about security. There's potentially personal information in some of the things that we handle, and so that isolation with namespaces and encryption, encryption by default, which the Istio service mesh kind of gives you, are all really powerful tools for us that we just get by using the platform. So we really reach for all of those things to make it easier to manage. As Seth kind of alluded to, we've grown our customer base quite a bit, and so there's a non-trivial amount of SQL instances to manage, and there's a non-trivial amount of namespaces and pods. But that's where Stackdriver and a lot of the other products that Google offers really come in to help you. But yeah, I would say the continuous release of new features of Kubernetes has made it a really great thing for us.
Yeah, we love Kubernetes. It's great. I sort of think of it as it's a nice abstraction for defining workloads. So we define workloads, and then Kubernetes just kind of makes them happen. And we heavily use namespaces as our isolation model. We also have really done a lot in the Kubernetes operator model, which is a thing CoreOS, declared a while ago. And it means we create custom resources. Resources are like an internal Kubernetes thing, pile of YAML. The resource basically says, this is a customer. They should get this many resources. They're big, medium, small, and make them go. And then we have an operator that comes along, reads all the resources, and creates the namespace, creates all the pods, creates the Cloud SQL instance. And so, yeah, I mean, Kubernetes is great, and I really like the operator pattern. It lets me take my knowledge of how to create and manage these things and translate it into code that just runs and synchronizes itself and kind of just goes in the background and fixes.
Any other tools you're using together with the Kubernetes? Terraform?
Yeah, so as you might have guessed from Amy, we use Terraform. We're actually on the journey to where Ceph already is, where the operator pattern, we've watched it closely and kind of seen people apply it successfully. Again, we're in an industry where we have to be a little bit more cautious. So we have to kind of watch things and make sure that they mature in the way that we really think that we can make a long-term bet on them. Kubernetes is a no-brainer. The operator pattern, it is a pattern. And so for us, we had to just see people successfully apply it. And there's a lot of great examples out there now and a lot of great stories from people like Ceph who have applied it. So that's where we're going to be going next.
Okay. So Joe, you touched about the security. So what kind of things that in the multi-tenant environment, how do you isolate each tenant to avoid any security concern? Is there any specific thing that you can share?
Yeah, I think just by the nature of having the single tenancy, you alleviate almost all of that concern. There are certain customers where they want that data to be on-prem, and that's a whole another thing that you have to address. But in a multi-tenant application, again, I think you really have to look at your business case. I've worked for companies that were under HIPAA compliance, and so in a multi-tenant application that has to have HIPAA compliance, you have to have row-level encryption, and then you have to reach for some tools like Vault, which is a HashiCorp product that allows you to have encryption as a service, or other things like that, because it's not just enough that you can. If someone was to access it, they can't even be able to decrypt it. And so business case is really what you really need to think about a lot of these situations.
Okay.
Yeah, I'm not sure I have much to add on the single tenant side. It is a great answer for a very strong data isolation. As said, if you go multi-tenant, you're basically pushing that burden to the application layer. We've often done it, in our multi-tenant world, we do it via the database adapter just enforces that. This is a call for data. It had better have a appropriate where tenant equals X clause on it. And frequently to handle the needs of really sensitive customers, you end up sharding by customer. So you end up kind of in a bit of a hybrid where most things are multi-tenant, but this one is special.
Okay. How about the noisy neighbor problem? How do you do the performance isolation?
Well, single tenant makes that pretty easy. In Kubernetes, you still have to think about it a little bit. Our pods are scheduled onto the same nodes, so we have to make sure that our pod resource allocations are correct. So each of our pods is allocated, so much CPU and so much RAM, and then Kubernetes will just enforce that. And that's how we approach the noisy neighbor problem.
Yeah, I kind of gave it away earlier, but that's we actually had a situation. We were doing what Ceph did, and a bug in our code essentially was causing cascading failures, where we were bringing down an entire node, and there was multiple customers on that node, and so our tech support team had a lot of angry phone calls all at the same time. So I ended up pulling over to the side of the road and doing a lot of work on my laptop on the side of the highway. So after that, we were like, okay, in the future, when we have more resources and our company's more mature and we can really get a lot of great people like Seth and other people like that, we can attack this. But for now, it's easier, again, to push that complexity to Google. Say, we're going to have node pools for every single customer, and we're going to set up the Kubernetes rules to make sure that no two customers can end up on the same node. So if something does happen and we roll out a bug like that again, it's going to be completely isolated. That is not a long-term, solution, probably, but for now, it's something that we can live with, and it's helped us continue to build our business.
I've actually sort of got we run into a certain problem around this, which maybe is funny if people want to hear about Kubernetes problems.
No.
No, it's great.
Yes.
What we've seen is Kubernetes itself can be a little weird. It's not quite a noisy neighbor, but it's almost similar. Like the underlying Kubernetes resource requirements per node are not small. So they're actually substantial. Like if you have each node has a given load, so you have to be cognizant of that. And the other thing we've run into, which is, I don't know, I giggle about it, but it's been a bit of a pain point, is some operations we do, if we go to upgrade everyone, right? We're basically running a redeploy on every one of our tenants. And what we found is that the Kubernetes master can get overwhelmed with that very easily, and then everything breaks. So it's very bad when your Kubernetes master breaks. So to sort of approach that scaling and kind of noisy neighbor, we basically just rate limit what we do. So we found that we have to be very deliberate in how we roll out upgrades, because otherwise the Kubernetes master just tries to do everything at once and then it melts.
So how many pods do you put per node?
This is another problem we've run into. Kubernetes, running in Google Kubernetes has a limit of 110 pods per node, which most people are okay with, because you normally run about 30, and this is kind of a pod resource to node capacity question. A lot of our services are very small, and we have a large number of tenants, so we pack them a bit. But what I've found is when we exceed about 50, things start going wonky. And it's just, there's a lot of auto-scaling in the Kubernetes system, and a lot of the scaling around Kubernetes metrics collection and logs collection is based on the idea that you will only have about 30 pods per node. So as you start pushing that higher and higher, you run into these points where things you didn't expect would break.
I see. So you recommend about 30?
Yes, I would recommend not exceeding 30 to 50 pods per node.
So do you have any scaling experience? Like maybe in the Black Friday, I'm sure you guys are very busy.
So as all of you would probably recognize, our customers can have something like a 20x peak where everyone wants to order something on a Black Friday and they want it the next day. And so for us, that's where Kubernetes really shines for us also is, okay, we all of a sudden got 20 times the orders that our system normally needs to ingest. And so being able to both scale vertically and horizontally inside Kubernetes gives us the flexibility to kind of not have to worry about that as much. We obviously take a lot of precaution and we're trying to be ready for that. But as a technology, it's really enabled us to, again, do more with less. And that's really what I think a startup is all about is, you need to keep your most talented people focused on the product and not focused on, oh no, we need more nodes. Quick, click the button more. And that's where Kubernetes comes in.
That's great.
Maybe sort of thinking a bit about that, though this might be a future question. I don't know. Sorry, Amy.
It's okay.
One of the things that helps us a lot in handling sort of momentary bursts in traffic is we have a predominantly asynchronous pipeline. We're trying to reason about things on a minute to couple of minute timeline. So if a big burst comes in, it's kind of just going to hang out in a queue until we can process it. So as long as our queues have capacity, it's okay if our processing is a little bit lagging. And I can't speak for Joe, but I bet there's something similar.
We're getting there. I think, you think about logistics in these companies, they're often very old. And so we're integrating with systems that expect transactions, for example. So we don't care that we gave you 2 million things to do. We're just going to sit here and wait for you to tell us if you did 2 million things. So a lot of our infrastructure needs to just really be able to absorb that. We do some batching and everything else, but it's a problem that is difficult to solve. And the infrastructure can't always solve that problem, but good design where you build queues and everything else can help.
Sure. Now let's move on to more customizability. So you guys have a single tenant environment. So how similar to each tenant, the characteristic, and if the one tenant is a very different characteristic, how do you customize those things?
Yeah, that's a really good question. For us, it's kind of around the size of our system. So customer A has eight chucks and customer B has 50. We have kind of like, we put those numbers in and out the other side pops, oh, well, they should get this size of database, or they should get this size of node pool, or this amount of resources, because we know kind of exactly how a chuck's going to behave. It's a little bit more difficult if you have users or other things that you can't really predict. But luckily, we kind of control both sides of the equation there, so it can be really prescriptive for us.
We probably have about maybe 5 variables per customer. I don't remember offhand, but it's about 5. And we implement that by environmental variable. So our application says, hey, what's the value of this environmental variable, and it behaves a little differently. And then we just control those in our Kubernetes operator pattern. Our custom resource definition has some settings. The operator pushes those in as deployment variables, and then it all just kind of follows from there.
Okay, that's great. So now let's move on to cross-tenant environment. So when you need to do like analytics, the cross-tenant environment, how do you do that? Are you using any data warehousing environment?
We don't have that need, so we haven't done it.
None.
We do, as you would imagine, really want to know about all of our customers, and so it is an interesting problem for us. And we rely on BigQuery a lot, and so all of our robots are sending information through Cloud IoT that gets pumped into BigQuery, and then we also have some data pipelines that go to all of our SQL instances and scrape data, shove it into BigQuery. So we have one place where we can look at all of that. And we're lucky enough to be involved with kind of an alpha where Cloud SQL is able to be queried by BigQuery directly. And so we'll be happy to kind of get rid of that scraping situation. But yeah, it's really important. That is something that is a good thing to reason about, is if you're going to have that need. Ceph doesn't, but we definitely do, because we need to find efficiencies across all of our tenants. And so that's really important for us.
I see. Okay. And how do you forecast your demand, the capacity planning? Now you talked about the 30 instances that you keep it in your back pocket.
I mean, our capacity planning is relatively simple. We sort of look at what our marketing is like, and are we going to a conference? Do we expect signups? That kind of thing. And then we just kind of say, about this, and we do it. And overestimate it a little bit. Don't think too hard. We're still a very small company. We don't have this. I guess the other sort of implicit piece of that is, we don't have to buy hardware. We're just saying, hey, Google, instead of 30, give me 32, right? Like it's no different to me. It's a minute either way.
Yeah, I think we also have a pretty nice luxury where we kind of know our customers even tell us how many orders they expect on their Black Friday, and so we prepare for that by doing a lot of load testing, and that really helps us understand. We need to scale, this needs to auto scale this way, or we need to prepare our environment this way. So a little easier for us because we're dealing with large enterprise businesses.
Do you guys do any stress testing in your environment?
Yeah, actually, one of the cool things that we do in Kubernetes, as you probably can imagine, if we need to test 100 robots, we can't really just go with 100 robots to a warehouse and deploy them, and that's kind of a lot of money. So we actually run our simulators, so we run the same code that runs on the robots in Kubernetes. We scale that up to silly things that wouldn't be practical in the real world, and we are then testing our system the same way that it will be actually stress tested in the real world. So it's another place where Kubernetes is super useful for us, and another reason why it's a really great platform in general.
Yeah, we do something pretty similar, actually. I mean, no robots for us, but we run an endpoint on agents, and I can build the endpoint into containers, and spin 100, 1,000 of them up in a Kubernetes cluster and just point them somewhere. So we basically do the same thing, and it's a really easy way to just sort of have a really elastic, cool, let's point 100 of these at that, and we'll do we have enough capacity there? Which gives us a good understanding of the number of endpoints that can correspond with what size pods and how many pods, what does our horizontal scaling look like.
So now actually move back to database question. So how database is stateful. So how do you use together with the Kubernetes? Are you putting database in the Kubernetes pod or?
So we don't run our databases inside Kubernetes. We use Cloud SQL. It's great. It just runs. We don't think very much about it. The way Kubernetes talks to Cloud SQL, it's got a couple of intermediaries. So we use the Cloud SQL proxy, which is designed to proxy between things like Kubernetes and Cloud SQL. Google distributes it. You just kind of tell it to go. And we run Postgres, which means we also need some additional connection pooling. So each of our customer pods, each of our customer namespaces has Cloud SQL proxy instances and PG Bouncer instances as like an additional connection pooling layer there.
We actually started running databases inside of containers. Again, being more cautious. Postgres for Cloud SQL is in beta, and we were like, we'll just wait. And so we waited. But in that time, we had decent success. Kubernetes is a pretty stable platform using persistent volume claims, which allows you to have a disk that follows your pod around. We had minimal problems, but certainly the effort was not zero. I spent a lot of time tuning that. When we had the need for a read replica, that was a couple weeks out of my time to make that a thing. Since moving away from that model, and then there's also the problems. And so the problems are like, alert just went off. I'm running out of disk space. Got to go in there and get more disk space. That's not a problem on Cloud SQL. Just that auto scales right up for you. And so that was actually the main thing that I was running away from when that finally came out of beta. I was like, okay, great, no more disk space problems. Better alerting, and looking forward to the day where also auto scaling on Cloud SQL takes that out of the equation for me as well.
So whenever you have to create an instance in the Cloud SQL, are you using Kubernetes or Terraform to automate that whole process?
Yeah, so our whole thing is driven by Terraform. I've been using Terraform for quite a few years. It's a great product, and what it allows me to do is create what's called a Terraform module, which is much like what Seth was alluding to for an operator, but that module represents what is a customer, and that customer is a Cloud SQL instance, a DNS entry, a namespace, and all this other stuff. And then there's this tool called Atlantis, which allows you to manage all of these things through GitHub pull requests. And so essentially an upgrade in our world is a GitHub pull request, and then Atlantis runs Terraform and makes all those things happen. So it's really elegant for us, but there's always room for improvement and that sort of thing.
Yeah, for us, it's all driven by our operator, which is a daemon that we wrote. It runs in Kubernetes, but it isn't part of Kubernetes, right? It could run anywhere we put it. We run everything in Kubernetes, so that too. And it calls the API for Cloud SQL, creates it, waits for it to show up, make sure it does what it wants, and then it creates everything else.
All right. So I think we are almost of the time for Q&A, but I want to ask the last question. How many DBAs do you have in your team?
Just me, really.
I would say 0, only because I don't consider myself a DBA. So
that's great.
I am the guy that's on call, I guess.
Okay. Awesome. Thank you.